Okay everyone, welcome to our first video lecture for DQR 300. Today we're going to talk a little bit more about correlations and specifically how to compute them in SPSS. Now in class we computed correlations by hand and we learned how to interpret them properly, so let's just do a short recap here. A correlation measures the linear association between two variables, and it's usually denoted by the letter R statistically. You can explain correlations using the correlation strength and direction. So when you explain them on your homework assignments or in articles or papers that you write, you want to explain it by strength and direction. If you take a look here, we see a relatively strong or moderately strong positive correlation. On our x-axis, we have the hours studied for an exam, from few to many. On our y-axis, we have the score on the exam, from poor to excellent. As you would expect, we would see that there is a moderate positive correlation. The more hours that you study, the better you tend to score on an exam. If we take a look here, this is a strong negative correlation. On our x-axis, we have an irritability score here, from low to high. On our y-axis, we have the hours of sleep, from few to many. And you see here, as your hours of sleep decreases, your score on irritability will increase. So that would indicate a negative correlation. As one variable goes up, the other one. Okay, as you see here, we have an association. It is really not a correlation. It is reasonable to assume that our shoe size, as shown on our x-axis, is not associated with IQ, as shown on our y-axis. And you can see here that the correlation is indeed 0. Some people are unintelligent and they have big feet, and some people are not intelligent and they have big feet. So that really is how you explain a correlation using its strength and direction. Now, Cohen in 1988 kind of provided us with some guidelines on how to describe the strength of correlations, and he would suggest that small correlations would be up to and including 0.29. You can see here, whether it's negative or positive, a 0.29 or lower correlation is still a correlation. There's still an association there, but it's pretty small. Whereas correlations up to 0.49 or around 0.5, we would tend to call them moderate correlations, and correlations greater than 0.50 are strong or large correlations. Now, it's just important to keep in mind that these are guidelines for interpreting correlations proposed by Cohen in 1998. There's no real specific way to describe them. But this is what most psychologists and statisticians will follow through with. The last big thing about correlations is you need to remember that correlation does not equal causation. And you can see that nicely here in this particular figure. On our x-axis, we have chocolate consumption. And on our y-axis, we have the number of Nobel Prize winners. Okay? And as you see, the countries that consume more chocolate, they tend to have more Nobel Prize winners. And that's obviously not a causal factor. We don't think so. But we do see a strong positive correlation. Obviously, these things don't influence each other, but there is an association. So you see a lot of spurious correlations out there, so beware that you do not make causal conclusions about this. Alright, so that's just a little bit of a recap of what we learned in class. Now let's look at how we do this in SPSS. Okay, so here's our data view from our SPSS file. Once again, it looks like Excel. And we can direct our attention over here. We have two variables of interest. Our first variable is IQ. So we can see 12 participants' IQs here. Our second variable of interest is GPA, and we have those same 12 participants' GPA here. Computing a correlation in SPSS is very simple. Once your data set is open, you want to go to Analyze. Let me see here, Analyze. And if you go to Correlate, now here we're going to do bivariate correlations. That simply means the association between two variables. Partial correlations will be a little bit more extensive, and we can talk about them later. So I clicked on that, and you're probably going to see something that looks like this. So I want you to move all of the variables of interest that you want to see a correlation for over into this variables box here. So I'm going to click on IQ, send it over, click on GPA, and send it over as well. Now when you're working on other files, you're going to see all of the variables in the data set in this left-hand box. Here you have the opportunity to move only the variables you want to see a correlation for into the right side box. We're going to compute a Pearson correlation, so make sure that that is checked. There are different equations for computing correlations for different types of data you see here, but the ones we've computed are Pearson correlations. We're going to talk about significance testing later, so keep that at two-tailed and flag significant correlations here. Under options, you might want to take a look at the means and standard deviations, and if you click continue and OK, you're going to get a nice small output here. So we have our output window. We have, let's direct our attention to descriptive statistics, our IQ here. So the average IQ in our data set is 103.75 with a standard deviation of 14.58. And N, of course, equals the number of participants, so 12 participants in the study. We also have the mean and standard deviation for GPA here. Now, this is what you want to look at for the crux of this particular assignment. For each variable, for instance IQ here, we have the correlation. You know what that means now. And we have the significance test. Let's see, get that. Okay, the significance test is another name for the p-value here. And we have a p-value of 0.003. The p-value indicates that the p-value indicates the probability that our statistical test is due to chance. So we have a 0.3% chance that this effect that we see is actually due to chance and not a real effect. Remember, we are estimating or making an estimation about the population. So we're never exactly sure that our correlation will be seen in the population. So the significance test, which we'll be talking about in future lectures, is something just to keep in mind here. The probability that the result is due to chance. So if you take a look here, you're actually going to see the same value here because obviously we're looking at the correlation between GPA and IQ. So GPA here, IQ here, correlation here. You see it here as well. This is just a matrix. So the correlation is positive. It's pretty strong according to Cohen at 0.78. So that indicates there's a strong positive correlation between IQ and GPA. Now you know. So the last thing I'm probably going to ask you to do for your homework assignments and for future assignments as well is to write this up in APA format. So let's take a look at how you will do that here. Okay, let's report our results in APA format. Now when you do this for this class, or even when you do it for a research paper, or when you ultimately do it for your manuscripts, when you write scholarly articles in your future, you'll want to report your correlation like this. The first thing you want to say is tell the reader what kind of test that you conducted. So I wrote here, a correlation was estimated to test the association between IQ and GPA. The second thing you want to say is the results of the test. So what we have here is IQ and GPA were significantly correlated. Specifically, R was 0.78 with a p-value of 0.003. That tells your reader the strength and direction of the association. Finally, you want to say it kind of in layman's terms here. Higher IQ is associated with higher GPA. That's it. That's all you need to say for the correlation. Then you would go on to explain it in your discussion section. Okay, so hopefully this gave you a better idea of how to go about computing correlations in SPSS. Please go on over to your workshop 4 and complete the assigned work. Thank you.